Is my screen visible?
Oh, yes, sir.
Okay. So firstly, tell me, how was your class 11th maths? Which topics you were very good with, or in which topic you struggled? Tell me something.
Sir, I struggled with limits,
Limits. Okay.
yeah, and trigonometry,
Trigo also. Okay.
yeah, and I was good at um, I forgot the name of the chapter, the GP, geometric progression.
That means you are good at with algebra sections like inequalities,
Yes, sir.
sequences, binomials, right?
Yeah,
Okay. So basic algebra you are good with. And coordinate? Coordinate
yes, sir.
geometry?
I'm good.
Coordinate? Good. Okay. You are clear with the concepts of straight line, circle, parabola, ellipse, hyperbola.
Yes, sir.
Okay. Coordinate geometry. And how was your probability?
Sir, probability was good.
Okay. Okay, I got the rough idea. You are clear with the basic concepts of set, relation, and functions, or had doubt?
Yes, sir.
Okay. You are clear with the basic concept of set, relation, and functions. Set, relation, and functions. Okay, it is good thing, but one thing that is there that you are lacking in trigo part. And if I ask you about that, in which section in trigo? The proving.
Yes, sir. The proving part.
The proving part, that how to manipulate and get the RHS, those things. You are clear
Yeah.
with the basic formulas, you remember now or not?
Yes, sir.
Okay, tell me the formula of cos 2 theta.
Uh, Cos 2 theta,
Yes.
2 cos theta sin theta.
It shows you are not good with sine
I
2
need to
theta
revise
is
it.
sine 2 theta is 2 sine theta cos. Okay, you haven't revised, I understand, no issue, but you must have related these things. Let's start discussion from trigo only, because I want to know you better, so that we can analyze our further classes and structure our classes. Okay, so if I ask you in trigonometry, what was the formula of sine a plus b? You remember this or not?
Yes, sir.
What it is?
Sin A cos B plus cos A sin B.
Good. Sine a cos b plus cos a sine b. And here it is itself, if I ask you to find sine 2x, what it will be? You don't remember now, right?
Yes, sir.
Okay. Can you find this by using this? Can you find sine 2x using the above formula? No.
No, sir.
That means you didn't analyze the derivation of this part. You can very easily find how. I can write it as sine x plus x. Obviously, 2x can be
Yeah.
written, right? Now, can I apply the sine a plus b? The answer is yes. Sine a into cos b plus cos a into sine b, and what we are getting? Sin x cos x plus cos x sin x. So finally, can I write it as sin x cos x plus sin x cos x? Can I write like this, or doubt?
Yes, sir.
And ultimately I can write it as 2 sin x cos x. That means I can very easily find the multiple angle formulas if I know these formula, the a plus b, sin a plus b, cos a plus b. If I know these, I can very easily find the multiple and sub multiple formulas. Clear?
Yes, sir.
Now can you correct for cos 2x? You know the formula of cos a plus b,
Yes, sir.
what it is?
Cos A, cos B plus sin A, sin B.
No, cos a cos b minus sin a sin b. Here it is plus. So in cos terms, it you'll have to take it negative. Okay, the formula for this is cos a cos b minus sin a sin b. You will have to at least remember this. Why I am starting from trigonometry? Because trigonometry will be continuously used over the calculus sections, whether be it limits, continuity, differentiability, AOD, you say integration, application of integrals. In all of these, trigonometry will continuously come. So you'll have to be very clear with trigonometry, the basic formulas. Now we have the formula of cos a plus b. Now if I ask, can you find cos 2x?
Yes, sir.
Find and tell me the answer.
Sir, cos square x minus sin square x.
Yes, correct. Cos square x minus sin square x. So from now you won't face difficulty in finding the multiple angles, right?
Yes, sir.
Okay. Even if you don't remember the formula, you can very easily find it. At least you will have to know about these. Okay, cos 2x we have. Can you write some other form of this? The answer is yes. What we can do, if I convert this particular part sin square x in terms of cos square x, can I write this as cos square x minus 1 minus cos square x? Is this correct?
Yes, sir.
That means, and from where I am getting this? Tell me.
Sir, it's because sin square x plus cos square x is equal to 1.
Correct. That means we are getting cos square x minus 1 plus cos square x. I can write it as 2 cos square x minus 1. So the first formula for cos 2x, we got it as cos square x minus sin square x, and the next formula is 2 cos square x minus 1. We can write it in another form also, in terms of sin square x. How? At this place only, if I convert this cos square x to sin square x, I'll get the answer. What I'll do, 1 minus sin square x, and there is already minus sin square x. That means I am getting 1 minus 2 sin square x. This is cos 2x. Clear?
Yes, sir.
Do we have now 3 formula for cos 2x? And this is very
Yes, sir.
important, because in manipulations, in the say in while we'll be integrating or say differentiating, it will come many times. So here cos 2x, cos 2x, cos 2x. Have you noted all this or not? Take note of all this.
Sir, I'm writing.
Okay, note.
Yes, sir. Done.
Okay. In the same way, we know about tan A plus B. What is tan A plus B?
Tan A plus tan B by 1 minus tan A tan B.
Correct. Tan A plus tan B by 1 minus tan A tan B. And similarly, if I ask you to find tan 2x, this time what it will be?
Tan of x plus x.
Tan x plus tan x by 1 minus tan x into tan x, right? That means I am getting
Yes, sir.
2 tan x by 1 minus tan square x. That means I don't have to particularly remember this. If I am able to remember or recall, it's good. But if I forget somewhere, what I'll do, I'll connect from here, right?
Yes, sir.
Okay. Now tell me, we just discussed some basic because you said that there are some lacking points in trigonometry. What we should do? Should we start a topic as a demo session from class 12 or we should continue this trigonometry? Tell me.
Sir, demo session for class 12.
Okay, let's start. But we'll have to build these while I'll be starting with say limits, continuity, differentiability or differentiation. Wherever it will come, I'll just discuss these things, okay, that from where it is coming, because without building on these it will be difficult for us to master all the calculus part. Okay, the first topic in class 12 is set this relation and function, you can say. Sets is already over. The first topic is relation and functions. Now again I'll start with class 11 because without those basics it will be difficult to discuss relation. Now tell me, what do you understand by set? Are you clear with the set?
Yes, sir. Like, a set of odd numbers or a set of even numbers is like
That
2,
means there is
4, 6.
yes, yes. That means we write some elements with some defined part. These kind of things. Like I can write a set A as 1, 3, 5, 9, dot dot dot. This is odd number set. I can write some set B as 2, 4, 6, 8. I can close here also, and if I want to include all the even numbers, I can just write dot dot dot, right? That means collection of well defined objects. We generally say collection of well defined objects. There are few things I won't discuss set completely because we have to discuss relation and function actually, but there are few things that you should be very clear. In set there are two ways to represent. What they are?
Sir, like represent what?
Represent, if you want to represent any set, there are two ways. The one is roster form,
Set builder form.
set builder form, right? In roster form what we do?
In roster form, we like they'll be given x such that x belongs to. They will be given some criteria, and we need to write
In
that
roster
in the
form,
form of a set.
in roster form,
So no, in roster form they'll be given the set, and then like we need to write the x such that x belongs to,
no,
like that.
in roster form what happens, all the elements are written. That means if I have to write in roster form something, I'll write it as 1, 2, 3, 4, 5. Suppose I have made a set in which 1, 2, 3, 4, 5 exist, okay? So this is roster form. If I have to represent the same set in the set builder form, what I'll do, I'll define a rule. That means I'll write x is such that x belongs to n and x is less than or equal to 5. Is this clear?
Yes, sir.
Okay. So roster form, what happens? We write all the elements. Is this visible now?
Yes, sir.
Okay. So in roster form, we write all the elements. And in set builder form, what we do? We define a rule. So this is about set. One more concept that we should be very clear in set is about subset. What it is, subset? Tell me. What is subset?
Sir, subset contains all the elements of a set. Like, like if a
Okay,
set is
let's understand with
1,
example.
2, 3.
Let's take an example. I'll ask you the subset. If I have 1, 2, 3, what subsets possible for this set A?
Sir, 1, 2, 3, and
1,
1,
2,
2.
yes, 1, 2,
Yeah,
1, 3,
and 2, 3.
2, 3, and 1, 2, 3 also, and one more element, 5, right?
Yes, sir.
That means empty set is the subset of every set. That means 5 should belong, and set is the subset. That means any set is the subset of itself also. So we are including 1 to 3, and these are very clearly that these have been formed from 1 to 3. So how many elements we can find? 8.
Yes, sir.
And for this only you must have gone through a formula 2 to the power n. That means if you have 3 elements, what you will do, you will just do 2 cube and you will get 8. That means there will be 8 subsets of this set. So if we are clear with all this, we can proceed to relation. Note all these properly.
Yes, sir.
Have you noted all this?
No, sir, 1 second.
Okay, note.
Yes, sir, done.
Okay. Now let's come to the important topic, relation. And slight idea of relation also you must have got in class 11. Tell me something about relation. What you understand?
Sir, in relations, like, if a set can have a lot of like relations.
That means you want to say associations kind. That means element from set A can be associated with the other elements. Yes, obviously we
Yes,
understand
sir.
this, but it is difficult to just convert these into words. So I am giving you few words, like whenever you are asked to define relation, what you understand. Firstly, mathematically we can say that any subset of A cross B. A is a set, B is another set, and if you take any subset of A cross B, you will get a relation. This is mathematical definition, you can say. This is mathematical. If we just try to understand in simple terms, what we can say, any kind of association from set A to set B. We can say it as a relation. Let's understand with few examples. And we'll use firstly arrow diagrams to understand these. 1, 2, 3, 4, 5, 6, 7, 8. 1 is associated with 5, 2 is associated with 6, 3 is associated with 6, 4 is associated with 7. Can we call this as relation?
Yes, sir.
There is a relation from set A to set B. Yes, we can definitely call this as a relation. This is a relation. Because in relation, what happens? Any kind of association, there is no restriction. When we define a function that we'll discuss further, there will be certain restriction in these, that every element of set A should be associated and there should be unique association. But in relation, what happens? If you observe any kind of association from a set to another set, you can say the relation exists. We have to discuss the type of relation also. We'll come on that later. If I write 1, 2, 3, 4 and I just associate one element, can I call this as a relation?
No, sir.
No, this is also a relation, because any kind of association, there is no restriction. That means even if one element is associated, you can say it as a relation. This is also a relation. Clear?
Yes, sir.
If I take another example, set A 1, 2, 3, 4, 5, 6, 7, 8, and this time I write 1, 5, 1, 6, 2, 7, 3, 8. Is this a relation?
Yes, sir.
Yes, you don't even have to think, because in relation what happens? All kind of association will be a relation. There is no restriction that you have to keep in mind. So this is also a relation. Set A to set B. Now let's take one more example and it will be confusing. 1, 2, 3, 4, 5, 6, 7, 8. And now I have not associated any element. I have not associated any element. 1 is not associated with either of these from set B. 2 also, 3 also, and 4 also. Can we call this as a relation?
No, sir.
Yes, we can call. This is called empty relation. Okay, this is called empty relation. For understanding this, you will have to go to mathematical definition. What it was saying, any subset of A cross B, right? If I take,
Yes, sir.
I'll just take here an example. If I take A as 1, 2 and B as 3, and if I find this A cross B, what it will be? Ordered pair will form. Are you aware of ordered pairs? Here 1, 3, 2, 3. 1, 3,
Yes, sir.
2, 3. So these ordered pairs. Now it is saying that any subset of A cross B. So how many subsets will be possible? 1 will be 5. 1 will be 1, 3. Then 2, 3. Then both 1, 3 and 2, 3. Right?
Yes, sir.
So what we are able to observe, that even if there is no association, then also we say it as relation, and that is called empty relation. Suppose there are two families, and there are two families F1 and F2. There are 5 members, here also 5 members. but there are no members are talking to any other member of the other families. What kind of relation we can say? They are living in the neighborhood, but they are not talking. We can say they are avoiding each other, right? They are still maintaining a relation. Can we say it or not?
Yes, sir.
The relation of avoidance. So here also the relation of emptiness. There is no relation. Empty relation we can say. Okay. So this is the
Yes, sir.
basic concept of relation. Note all this. Noted?
Yes, sir.
Okay. Let's go further. In relation, are you aware of the concept of domain and range?
Yes, sir.
What is domain?
Sir, I can tell you with example. Like I don't know the actual definition.
Okay, what you understand with domain? You can say whatever you understand.
Sir, like if like the if you are given like a set and then like the first numbers are always
Yes,
shown.
yes, the first coordinates is called the domain, right?
Yeah.
Okay,
Yes,
and
sir.
the second coordinates are
Range.
range. And what is codomain?
Sir, codomain, I don't know.
Set B. Okay, just see here. Let's take an example. It would be better. We will understand the definition of domain and range also while we'll discuss functions, because that holds significance. 1 2 3 4 5 6 7 8. Okay, and here I associate 1 with 5, 2 with 6, 3 with 6, and 4 with 7. This is a relation. Whenever you observe an association, you can directly say it as relation. The question just left is whether it is a function or not. Relation,
Sir,
it will
your
be in
voice
all
is
the case.
breaking.
What? Hello? Is this audible now? Can you hear me? Hello, hello.
Yes, sir.
Okay. So here we have 1, 2, 3, 4. Here we have 5, 6, 7 association. I can write this relation as 1, 5, 2, 6, 3, 6, 4, 7. Right? And as you said, the first coordinate, suppose there is 10 also. Suppose the first coordinates is the domain. That means domain of relation R is what? 1, 2, 3, 4.
1, 2, 3, 4.
What is range?
5, 6, 7, 8.
8 is not associated. 5,
Yes, 5, 6, 7.
7. And what will be codomain? codomain is set B. Okay, and it is 5,
Yes, sir.
6, 7, 8, and it is not fixed like set B. Suppose if I write the B as the first set and A as the second set, the second set should be your codomain. Clear? Or
Yes, sir.
doubt? Okay, you won't have to confuse that here the first is B and the second is A, and you have written codomain is set B. So the first set will not be here, always the second set. If I am drawing a relation from B to A, then A will be my codomain. I'll find the domain from here, I'll find the range from here, whatever they are associated with. Okay, so this is the basic concept. Here itself I want to introduce with the basic function idea. We'll discuss in detail later, but I just want to introduce because you have some idea with the arrow diagram that what is actually a relation, and now here you can distinguish it with function. What do you understand by function?
Sir, function, like in function, like we have different associates.
Okay, it is a kind of relation because there also it will be, here also there will be some associations, so it is a kind of relation, but with some restriction. It is a kind of relation in which each element of set A should be associated with unique element of set B. Without this idea, we won't be able to understand function properly, that what actually the function represents, like how to find the domain, what is the basic idea behind the domain, what is the basic idea behind the range. Okay, so here what we are saying that it is a kind of relation, and here two words are important, each element of set A, and here unique, associated with unique element of B. Let's take few examples to understand it. If I take 1, 2, 3, 4, I take 5, 6, 7, 8, set A, set B, and I write 1 is associated with 5, 2 with 6, 3 with 7. Can we call this as relation?
Yes, sir.
This is a relation, we don't have to even think. This is a relation because this is showing an association. Can we call this as function?
No, sir.
Why?
Sir, it's because in like the set A, 4 is not associated with
Yes.
with 8. So
Yes, obviously. That means the first criteria is not getting fulfilled, and even if one criteria is not getting fulfilled, we can say this is not a function. So this is only a relation. This is only a relation. This is not a function. This is not a function. Clear?
yes, sir.
Okay, let's take one more example. 1, 2, 3, 4, 5, 6, 7, 8, and this time I associate 1 with 5, 1 with 6, 2 with 7, 3 with 8, and here let's take one more element, I include 9, and 4 is associated with 9. The first question is, can we call this as relation?
Yes, sir.
This is a relation. obviously. And can we call this as function?
Yes, sir.
Why?
Sir, it's because all the elements of set A are
The
associated with
first
different
criteria is
elements of
getting the first criteria is getting fulfilled. It is very clear that 1, 2, 3, 4 all are associated, right? What is the next
Yes, sir.
criteria? The next criteria is saying that it should be associated with unique element of B. Uniqueness here means that if 1 is associated with 5, 1 should not be associated with any other element. Are you getting? Here the uniqueness
Yes,
means
sir.
that if any element x is there and is associated with this, it should not be associated with the other element. Right?
Yes, sir.
And one more thing that we generally confuse it. Suppose there are two elements x and y, and here z. X is associated with z and y is associated with z. It is not just violating the second criteria. Here also it is unique association. How? Because x is only associated with z. It is not like that x is associated with any other also, right? So we have to see
Yes,
it
sir.
from the perspective of first set. Are you getting?
Yes, sir.
So this particular part is a relation. This is not a function. And why it is not a function? But we'll answer because 1 is associated with both 5 and 6. That means in relation, when I write, I'll get the pair as 1 5 and 1 6. And wherever we observe this kind of thing, we can say directly that when 1 is associated with both 5 and 6, that means it is not a function, it is just a relation. Okay.
Yes, sir.
From the first set, there should not be two arrows coming from the same element. But in set B, you can see the convergence of two or more than three arrows at one element. There is no issue in that. We'll be defining the different kinds of function, the one, many one, into, onto. We'll see the differentiation properly. But here, while we define the function, what we have to observe only two things: whether all the elements of set A are associated or not, or the second is they are uniquely associated or not. Anywhere doubt? Hello?
Sir, your voice is not clear again.
Hello, hello.
Yes, sir.
Anywhere doubt? Is everything clear? Is everything clear? Hello? Voice is not audible. Is there some Wi-Fi issue from your side? Because it is not the case with other classes. Why? Hello? Can you rejoin it? Because I think there is some network issue from your
Yes, sir.
side.
1 second.
Okay. Hello?
Yes, sir.
Now is it audible?
Yes, sir.
Okay. There was some network issue. Okay. No issue. Have you noted all this?
Yes, sir.
Okay. Now this time answer 1, 2, 3, 4, 5, 6, 7, 8. Is this a function?
Yes, sir.
How?
Sir, because our first criteria is approved. Like, all the elements of set A should be associated with set B, and at the same time, all are associated with unique elements.
Hmm. That means 1 is associated with only 5, 2 is associated with only 6, 3 is associated with only 6, and 4 is associated with only 7. So both criteria is getting fulfilled. We can say it as function. Okay.
Yes, sir.
Now you will definitely be very clear with the relation concept, the set concept, the function concept. Now let's discuss, because we have discussed a lot with the arrow diagram. I just want to connect the type of function here itself. We'll discuss everything again